So for number 26, they want us to take the area bounded between these curves here, which is this section in yellow, and they want us to revolve around the line y is equal to 5, so around this line right here. And so when we revolve this area around the line y is equal to 5, we're going to end up with a bunch of cylinders that go like so. And these cylinders, we can think of them as sort of unwrapping this infinitely thin sheet of paper that wraps around the line y is equal to 5. And this sheet, it does have an area, right? And so if we think of summing up all these cylinders, so for example, if I were closer, I would have a smaller cylinder like this. So if you think of adding up all these cylinders, it's going to give you a volume, right? Because if you add up areas, you do get a volume. You go from 2D to 3D. So we can say here that the volume is going to be the sum from wherever these curves intersect, right, of AY dy. So we're summing up the areas across the y-axis because this is a vertical sum in this direction. So let's find out where these curves intersect. We do have here the curve x squared minus y squared is equal to 7, and the curve, the other line is x is equal to 4. So first we have to express everything in terms of 4, right? So I have that x squared is equal to 7 plus y squared. And so if I plug in the value of 4, I'm going to get 16 is equal to 7 plus y squared. And so I'm going to have here that 9 is equal to y squared, and therefore y is equal to plus or minus 3. So we can see that it goes from -3 all the way out to +3 of our sum. So the volume goes from -3 to +3. And all we have to do now is to find a way to express this area here as a function of y, right? Because if I can express it as a function of y, then I can put it in my integral and sum it up across the y-axis. So let's think about how we are going to do that, right? Well, the first part here, and maybe I'm gonna do this in a different color. I'll do it in blue. So this base here that gets revolved is the same as this base right here, right? And think about this area, because this area is base times height, because it's a rectangle. So the base is going to be that chunk between the two curves. And let me just erase this stuff so it doesn't get crowded. So let's think about how we get that little chunk there, right? Well, this chunk is the distance from 0 all the way out to x is equal to 4 is this distance right here minus the distance of where it touches that red curve, right? So if I do the value of 4, which is this vertical line that goes like this, 4 minus the value of whatever that function in red is, or that equation rather, it's going to give me that blue chunk. So as we can see here, the blue chunk is going to be the line 4. So it's going to be 4 minus the red curve. And now the red curve, x squared minus y squared is equal to 7. We do have to express this as a function of y. So what we're going to do here is isolate x. X squared is equal to 7 plus y squared, and therefore x is equal to the square root of 7 plus y squared. And this is the positive root, right? You're going to have a negative and a positive root, and the side, the one that we're working with here is the positive root. So this is going to be 4 minus the square root of 7 plus y squared. So there we go, we have the base. And now we just have to think about what the height is going to be, this section. And as we can see here, the height is going to be the base of my cylinder, right? And so the base of any cylinder, the circumference is 2 pi r, but r is no good for us because we're integrating with respect to y. So we do have to find a way to express this radius in terms of y. And let's see how we express it. Well, the radius here, this distance, it goes from, it's centered at 5, right? And it goes down to wherever I'm at on my y-axis. However, I can't say that this distance in blue is the height of y because, and let me erase these two here, because y is typically measured down up, right? Y is measured all the way down to up. So as we can see here, this blue section is going to be the distance of 5, that's the total distance, minus the height of y, right? Because it's wherever I'm at on my y-axis. So at this point, I'm maybe around y is equal to 1.5 or something. So it's going to be 5 minus 1.5, which is going to give us that 3.5-ish kind of distance, right? So as we can see here, this radius is, going to be 5 minus y. Therefore, our circumference is going to be 2 pi times 5 minus y. And so we now have an expression for the height, 2 pi times 5 minus y. Let me delete all of this. And so once we have a base times height, we do have an area, right? So area is equal to base times height is equal to 2 pi 5 minus y times 4 minus square root of 7 plus y squared. And so this is our expression for the area, right? So at any value of y, if you plug it into the expression, it's going to give you the area of this rectangle, which in fact is the cylinder that wraps around the line y is equal to 5. So our volume is just basically going to be that sum, right? So for the volume, we're going to sum from -3 to +3. 2 pi goes outside, and that is the sum of 5 minus y times 4 minus square root of 7 plus y squared dy. And and over here, the problem tells us to use a calculator to integrate it, right? So if I put that in my integrating calculator, let me see what that gets. Volume is going to be equal to, that's 163.02712. So this is the volume that I get when I take this area here in yellow and I revolve it around the line, y is equal to 5.